the three successive terms of a GP with common ratio R, where R is greater than 1, are the length of sides of a triangle, and this box is representing the greatest integer less than or equal to R. Then we need to find the value of this quantity, 3 into greatest integer of R plus greatest integer of minus R. So let us say that we have a triangle ABC, and in that triangle the smallest side is, let us say, A, and because the common ratio, let us say that this side BC is small a, and because the common ratio is greater than 1, common ratio is R and it is greater than 1. So the next side will be A into R, and A into R, that will be bigger than A, right? And let us say that the third side is AR square. Now we know that in any triangle, sum of two sides is always greater than the third side. That means A plus AR, this should be greater than AR square. Similarly, A plus AR square, this should be greater than A into R. And finally, AR plus AR square, this should be greater than A. So basically, we need to solve these three inequality, and from there we need to find the range of A. And then we have to see what should be, we have to find the range of R, and then we have to see what should be the greatest integer of R and greatest integer of minus R. However, one simple trick, and you can save considerable amount of time in solving these inequalities. The trick is that because for the given GP, the common ratio is greater than 1. So in that triangle, the smallest side is A, next the smallest side is AR, and then the biggest side is AR square. So if I satisfy the first inequality, that sum of two smallest side is greater than the biggest side, then other two inequality will always be satisfied. Right, if I satisfy inequality 1, that sum of two smallest side is greater than this biggest side AR square, then obviously out of these two, AR square and AR square is a bigger number, and in that we are adding A. So the second, and using similar logic, you can show that this third inequality, this is also always satisfied. So basically we need to solve the first inequality. There is no need to solve second and third inequality because this will be always true. Now for solving the first inequality, you can take A common and you can cancel A because A is positive. So then we are getting R square minus R minus 1 less than 0. Right? We can take everything on one side. A we can cancel. So R square minus R minus 1, that will be 0. And now we need to solve this inequality using number line. So, and also it is given that common ratio is bigger than 1. So we have to focus on R greater than 1 only. Now, if you solve this, then the roots that you will get is 1 plus root 5 by 2, and the other one will be 1 minus root 5 by 2. But 1 minus root 5 by 2 will be smaller than 1, right? So the positive root will be 1 plus root 5 by 2. And when R is bigger than that number, we'll get positive sign for this one. And between 1 and 1 plus root 5 by 2, this will be negative. That means the range for R, this will be from 1 to 1 plus root 5 divided by 2. Right? Between the roots, we'll get the negative sign. And because it is given in the problem that R is greater than 1, so we are solving the inequality only when R is bigger than 1. There is no need to solve for R less than 1. So between these two roots, between the roots, we'll get minus sign. So, and because R is greater than 1, so the range for R will be from 1 to 1 plus root 5 by 2. Now 1 plus root 5 by 2, this will be less than 2, right? Root 5 will be slightly more than 2, certainly less than 3, right? So this number is uh, less than 2, right? This number 1 plus root 5 by 2, this is less than 2. So now if we talk about greatest integer of R, so R is between 1 and 2, more than 1 and less than 2. So greatest integer of R will be 1, and greatest integer of minus R. Now minus R will be between minus 2 and minus 1. So greatest integer of that will be minus 2. So 3 minus 2, that will be plus 1. And that is the correct answer for this problem. Right, so in this problem, the important take was that because common ratio is greater than 1, so AR is the smallest, A is the smallest side, then AR and then AR square. And once I solve the first inequality, the other two inequality, these two are always true, right? So from there we got range for R from 1 to 1 plus root 5 by 2. And hence, when you calculate the value of this expression, you will get 3 minus 2, that is 1. And that will be the correct answer for this problem. Let A be this set 1, and then we have A1, A2 up to A18 and then 77. So total we have 20 terms in this set, A1, A2 up to A18 and then 1 and 17. This is the set of integers with uh, these numbers in increasing order. So smallest one is 1, then A1, A2 up to A18 and then 77. There is another set A plus A, which is set of x plus y, where x and y belongs to A. And this set A plus A contains exactly 39 elements. Then we have to find A1 plus A2 plus A3 up to A18. Now, in this problem, the important concept is how to decode this line, right? A plus A, this is set of x plus y, and x plus y, x and y both are taken from this set E. Now, in order to decode that line, we'll take two very basic example. Let us say we have one set A, and in this set we have these four variables A, B, C, D. Now, here if I ask that how many elements are there in this set A plus A, where you are taking one element, I mean, you are taking A plus A is this set, x plus y, and x and y both are taken from A. So if I take two numbers from here, right, and you can take the same number also, so then how many different sum you can create? So for that, the answer is that if I pick any two numbers, the number of ways of selecting that will be 4C2. So for example, you can select A and B, or you can select A and C and so on. So pick any two number that will give you one sum. Plus, there are other four sums that you can create by taking the same numbers, right? So, I mean, 4C2 means you have selected AB or AC or AD or BC or BD or CD. So, those are the six sums that you can create. And another four sum will be A plus A, B plus B, C plus C, and then D plus D. So, if we have four distinct elements A, B, C, D, then the number of elements in A plus A, this will be 4C2 plus 4. If there are n elements, it will be NC2 plus n. NC2 is number of ways of selecting any two numbers, and another n sum you can create if you select the same number, right? If you select AA or BB or CC or DD, then another four sum you can create. So here basically in A plus A, total you will get 10 elements. By using that logic, in a set A, if I have 20 elements, then how many different sum we should get? So for that, the answer will be, it should be 20C2 plus another 20. These many elements should be there in this set A plus A. Right? 20C2 will be 190 plus another 20, so that will be 210. But in the problem, it is given that we have only 39 elements in A plus A. That means many of the sum will not be distinct, they will give us same sum. Right, so let us take another example and try to try to understand that why we are getting only 39 elements in A plus A, whereas the total number of sum that should be, total number of elements should be 20C2 plus another 20. So for that, take another example. Let us say if I have four elements, and this time we have 1, 2, 3, and 4. Now in this set A plus A, how many elements are possible? So if I take 1 and 1, we can get a sum of 2. If I take 1 and 2, I'll get 3. 1, 3 will give us 4. 1 and 4, this will give us 5. Now, if I take 2, 1, or let us say 2, 3, we are getting the same sum. Next sum will be 2 plus 4, that will be 6. 3 plus 4, that will be 7. And 4 plus 4, that will be 8. So these are the only 7 elements in this set A. Right? So now the number of elements that we are getting in A plus A, this is 2n minus 1. Right? In set A, we had 4 elements. In A plus A, we are getting 7 elements. So number of elements in A plus A, this is 2n minus 1. So basically here many of the terms they will combine to give a single elements, right? For example, by adding 2 and 3 we are getting 5. Now the same sum you are getting when you are adding 1 and 5. By adding 2 and 4 we are getting 6. Same sum we can get if we add 3 and 3. So basically the idea is that if terms are in AP, then many of the sum will many of the sum will give us the same result. And if there are n numbers in AP, then number of elements in this set A plus A, this will be 2n minus 1. So if all the sums were distinct, then number of elements in A plus A, this will be NC2 plus N. But if the terms are in AP, then many sum will combine and they will give you only a single term there, right? So if the terms are in AP, then total number of terms in A plus A, this will be 2n minus 1. Now here in set A, total we have 20 elements, and in A plus A, we are getting 39 elements, which is 2 into 20 minus 1. So basically here, all of these numbers, they must be in AP. Then only you will get 39 terms. Otherwise, the number of terms in A plus A will be more than 39. And what will be the maximum number of elements in A plus A? If all the sums were distinct, the answer will be 210. 20 C2 plus another 20. Now here, once you establish that all of these numbers must be in AP, because there are 39 elements in A plus A. So these numbers 1, and then you have A1, A2, A3 and so on up to A18 and then 77. These must be in AP. Then only you will get only 39 terms. Now the problem is very simple. We need some of these 18 elements. So if here you can very easily see that these 18 numbers are nothing but 18 arithmetic mean between 1 and 77, and we know that sum of n arithmetic mean between any two numbers, this is nothing but n times single arithmetic mean between those two numbers, right? That is, otherwise also you can solve this. If these 20 numbers are in AP, you can get the common difference and then from there you can find sum. But if you are familiar with this result, that if there are n arithmetic mean between two numbers A and B, so then the sum of those n arithmetic mean, this is nothing but n times the single arithmetic mean between those two numbers. So then in one line you can get the sum, right? This sum will be 18 times single arithmetic mean between 1 and 77. So 1 plus 77 by 2. So that will give us 39 into 18, which is 702. So therefore the correct answer for this problem will be 702. Right, so this was a very interesting problem, and here the important concept was that if in A plus A we have 2n minus 1 elements, then all the elements of set A must be in AP, right? Also, if all the sum are different, then total number of elements in A plus A, this will be NC2 plus N, right? And once you establish that these numbers are in AP, A1 plus A2 up to A18, this is sum of 18 arithmetic means between 1 and 77. So that will be 18 times single arithmetic mean between those two numbers. Finally, after calculation, you will get 702. And that is the correct answer for this problem. Find the sum of common terms of following three arithmetic progression. The first one is 3, 7, 11 up to 399. The next one is 258 up to 359, and the last one is 2712 up to 197. Now we know that if we have a number of APs and if we find the common terms of all the given AP, then this will form another AP. And for that common terms or the AP of common terms, the common difference is LCM of common difference of all three APs, right? So here for the first AP, the common difference is of 4. For the second AP, the common difference is of 3. And for the third AP, the common difference is of 5. So for the AP of common terms, the common difference will be LCM of 4, 3, and 5, that is 60. Now, because we need sum of common terms, so we have to identify the first common term and the common difference of that AP, and then we have to see that how many terms we are going to get, and we need to calculate sum of all those terms. Now, finding common difference is not difficult because it will be LCM of common difference of all three APs. So we got LCM as 60. However, finding the first common term, that is A, right? Finding the first term which is common in all three AP, that can be tricky. For 2 AP, again by observation, you can very easily see if I have only first and second AP, then you can see 11 is the first common term. Or if I have first and or maybe second and third AP, then this 2 is the first common term. But here we need a term which is common in all three AP, and this can be tricky sometimes. So for that, here what we'll do is that instead of finding the common term of all three AP, first find the AP of common terms of any two APs. Right? First find the common term of any two AP. So for example, let us say if I consider the second and third AP, so first common term is 2, right? So the common terms of second and third AP, first common term is 2. And then after that, for this one else, for second AP, the common difference is 3. And for this one, common difference is 5. LCM of 3 and 5, that will be 15. So that means next common term will be 17, right? 2 plus another 15. Similarly, 17 plus another 15, that will be 32. 32 plus 15, that will be 47. 47 plus 15, that will be 62, and so on. So this is the common term of second and third AP. Now write the general term of first AP and then identify which is the term, which is the first term of this common AP of second and third AP, which is also present in first AP. Right, so you can see that in first AP, the common difference is of 4. So the common term will be 4m, the general term will be 4m minus 1. Right, all the numbers are multiple of 4 minus 1. You can see that 7, 11, 15 and so on. All of these numbers, they are multiple of 4 minus 1. So that means for first AP, the general term is 4m minus 1. Now try to identify that which is the first term, which is of the form multiple of 4 minus 1. 2 will not work. 17 is multiple of 4 plus 1. 32 is multiple of 4. 47 is 48 minus 1. And 48 is multiple of 4. So this is the first term which is of the form multiple of 4 minus 1. That means the first term which is common in all three AP, this will be 47. So in this manner, one can very easily find the first common term in all three AP. Write the common AP of any two AP and then write the general term of the third one and then identify which is the first term which is present in that the third AP, right? So 47 is clearly present in all the three APs, right? 40, and it will be the first term which is present in all three AP. So the first common term is 47, common difference is 60. The question was we need sum of all the terms. So first term is 47 and there are only few terms here. You can see that last term is 197. So common term cannot be more than 197. So directly we can find the sum, right? There is no need to use the general formula for sum of n terms. So first common term is 47. Next one will be 47 plus 60. So that will be 107. 107 plus another 60, that will be 167. And 167 plus 7 plus 60 will be more than 197. So therefore this sum will become, after adding this, you will get 321. So therefore sum of all the terms common in the 3 AP, this will be 321, and that will be the correct answer for this problem. An arithmetic progression is written in this manner. In first row you have only one element 2, then in second row you have 5 and 8, in third row you have 3 elements and so on. The question is what is the sum of all the elements in 10th row, right? Now as you can see that in first row we have one element, in second we have two, third one 3. So in 10th row we'll have 10 elements. All of those 10 numbers will be in AP, and for that AP the common difference will be of 3, because you can see that we have all the terms, the different terms of an AP with common difference 3. So in 10th row we'll have 10 elements. For all of them will be in AP with common difference 3. Now we know that formula for sum of n terms of AP is n by 2, and then you have 2a plus n minus 1 into d. This is the standard formula for finding sum of n terms of AP. Now, as you can see that there are three unknowns in this formula, n, a, and d. Common difference d, this will be 3. Number of terms n, this will be 10 because we have 10 elements in 10th row, right? The question is, what will be the first term of 10th row, right? We need to find this a here and then we can easily get sum of 10 terms, right? Now, for finding the first term, there are different methods, right? Here the major part of the problem is to find the first term a, right? Once we get a, the first term of 10th row, right? The first element of 10th row, then we can easily get the sum. Now, for finding the first term, one approach will be that if you notice the first term here, 2, 5, 11, 20, and so on, for these terms, their difference is in AP, right? For example, difference between 2 and 3, this 2 and 5, this will be 3. Difference between 5 and 11, this is of 6. Difference between 20 and 11, this will be 9. So as you can see that difference, if we talk about the series of the sequence of first term, for that one, difference is in AP, right? And we know that if difference is in AP, then we have this standard formula that nth term will be an square plus bn plus c, right? This is the standard formula for finding the first term. And how to get the value of ABC? So for that, when you can use the different equation, that first term is 2. So that means a plus b plus c, this will be 2, right? Similarly, for this sequence of first term, the second one is 5. First one 2, the next one 5. So T2, this should be 5. That means 4a plus 2b plus c, this will be 5. And T3, this is 11, right? We are talking about the sequence of first terms. So because for them common difference is in AP, the general term will be an square plus bn plus c. First term is 2. In place of n, if we write 1, we'll get a plus b plus c, so that will be 2. Second term is 5. And third one is 11. So in place of a, if we write in place of n, if we write 3, then we'll get 9a plus 3b plus c, this equals to 11. And now by solving these three equations, three unknowns, we can easily get the value of a, b, and c. Once you have a, b, c, you will get tn, and then you can calculate t10, right? Because the first term of 10th row, that will be the 10th element of this sequence. That will be one method. However, there is another interesting method of finding this a, right? Or maybe I'll just replace this a with alpha because a we are using for here. So let us say alpha is the first term of 10th row. So here alpha, there is another easier method of finding this one. One method will be you can use this general method an square plus bn plus c. Another approach will be that in first AP we are using one term. In second one we are using two terms of this AP. Now we are talking about this AP 2, 5, 8, 11, 14 and so on. Right? This is the AP that is there. Right? Now in first row we have one element, so we have used one term of this AP. In next row we have two elements, so we have used the next two element of the AP. Similarly, by the time we complete the ninth row, we have used the first 1 plus 2 plus 3 up to 9 elements of this AP. So the first element of 10th row, that will be nothing but this particular term of this AP 2, 5, 8 and so on. So here if you calculate this number, this will become 9 into 10 by 2. So it is 45 plus 1, 46. And T46, this will be A plus 45 into D. Right? Now A is 3, A is 2 and the common difference is 3. So that means in place of A, we can write 2 and the common difference is of 3. So 45 into 3, that will be 135 plus 2, that will be 137. So this should be the first term of 10th row, right? Alpha or the first term of 10th row, that will be 137. And now we can easily get the sum of all the elements in 10th row using this standard formula. So we have n by 2, that means 10 by 2, 2a. So 2 into 137 plus n minus 1, n is 10, so n minus 1 will be 9 and this multiplied by common difference 3. So from here we can get the value of S10. This will become 5 into and 137 into 2. So 274 plus 27. So that will be 301. 301 into 5. So 1505. Right. So finally, the correct answer for this problem will be 1505. That will be the right answer for this problem. Right. So in this problem, the important concept was, to find this first term A, this was the important part of this problem. Number of term will be 10. Common difference is also 3. All we have to do is find the first term or first element of 10th row. For that, one method you can use is that, because for the sequence of first term, the difference is in AP. Tn is, let us say, an square plus bn plus c, and now three equation, three unknown. By solving this, you can get ABC. Another easier approach will be that, because in first row we have used one element, in second row we have used two elements, and so on. So by the time we have completed 9 row, we have used the first 45 elements of that AP. So the first element of 10th row, that will be the 46th element of that AP. And by using the formula of nth term of AP, we got alpha as 137. And once you substitute the value of alpha here, sum of all the elements will be 1505. And that is the correct answer for this problem. If the sum of first 20 terms of this series is m by n, where m and n, these two are co-prime numbers or relatively prime numbers, then we have to find the value of m plus n. Now, this is another interesting problem on Vn method. Right here, whenever you have a number of terms in denominator, then we have to write the general term as difference of two consecutive terms. And then once you start adding them, the alternate terms will cancel. So here first let us write the general term Tn, and then we'll see how to write that as Vn minus 1. Right. So in numerator you can see that we have 4 into 1, 4 into 2, 4 into 3. So in nth term it will be 4 into n, and this divided by, in denominator the first term is always 4. Then next one is 3 into 1 square, 3 into 2 square, 3 into 3 square. So it will be 3 into n square. And 1 raised to 4, 2 raised to 4, 3 raised to 4. So this will be n raised to 4. So this is Tn. Now, as you can see that in denominator, we have a biquadratic polynomial. Now, in these type of problems, the standard technique is that write Tn as Vn minus 1. And then when you add, the alternate terms will cancel. Now, in order to write in that form, first we need to create factors in denominator, right? So here we can write this one as 4n, that will be the numerator part, and in denominator we have n raised to 4 plus 3n square plus 4. Now, in order to create factors here, this 3n square, this you can write as 4n square minus n square, right? If I write 3n square as 4n square and then minus n square, then you can see that first three terms, this will form a perfect square. And then we can use the formula of a plus b, a minus b. So 3n square, I'm writing as 4n square minus n square. And now when you combine these three terms, then it becomes n square plus 2 square of this one, and then minus n square, right? N raised to 4 plus this 4n square, this is 2 into 2n square, and here we have 2 square. So this is Tn, right? Now in next step, in denominator you can easily see the factors a plus b. If I use a plus b into a minus b, then you have n square minus n plus 2, that will be one term, and the another one n square plus n plus 2. Also, if you see the difference of these two terms, the difference, if I take the difference of these two factors in denominator, you will get 2n. So the 4n in numerator, that you can write as 2 into 2n, and this 2n you will write as n square plus n plus 2 minus n square minus n plus 2. Why? Because our aim is to write this as difference of two consecutive terms. And now you can see that if you separate this one, then you will get twice of, and in first one n square plus n plus 2, that will cancel. So we have n square minus n plus 2, right? In first term, you will get this thing in denominator. And in second one, the other term will cancel. You will get this one in denominator. So this first one you can write as 2 plus, and if you take n common, then you have n into n minus 1. This is first term. Minus the second one will be 1 divided by, and in denominator, again you can take n common. So you have 2 plus n into n plus 1. So finally, this is the general term Tn, and clearly you can see that this is these are two consecutive terms, because if I replace n with n plus 1 in first one, right, in this one, in place of n, if I write n plus 1, then you will get the next term, right? So this is Tn as Vn minus Vn minus 1. And now the question is, we need sum of first 20 terms. So here if I write T1, T1 will be twice of, and in place of 1, if I write 1, then it will be 1 by 2 minus 1 by 4. This is first term. Similarly, second one will be twice of. Now, in place of n, if you write 2, then this will become 4 minus 2 into 3, 6 plus 2, that will be 8. Similarly, you can see the pattern here. If I write T3, this will become twice of, then 1 by 8 minus, and 3 into 4, 12 plus 2, that will be 14. And in this manner, if I write the 20th term, then this will be twice of 1 by, and then 20 into 19. So that will be 380 plus 2. So that is 382 minus, in place of n, if I write 20, then we have 20 into 21. So that will be 420 plus 2, 422. So these are the expression for T1, T2 and so on. Now if I calculate Sn, or rather S20, sum of all these 20 terms. So this will be 1 by 4 will cancel, 1 by 8 will also cancel. Everything will cancel except this 1 by 2 from first term and 1 by 422 from the second term. So sum of these 20 terms, this will be twice of 1 by 2 minus 1 by 422. This will become 1 minus 1 by 211. So this will be 210. This divided by 211. This is this is sum of 20 terms. Now, as you can see that there is no factor between these two terms, right? So these two are relatively prime number, or their HCF is 1, and we are getting 210 by 211. The question is, we need the value of m plus n, right? So m plus n, m is 210, n is 211. If you add these two, then you will get 421. So the correct answer for this problem will be second option. Right. So in these type of problem, the important concept is that you need to write the general term Tn as Vn minus Vn minus 1. And for that, you need to create factors in denominator. And then whatever difference you have here, create that difference in numerator. And now Tn is Vn minus Vn minus 1 or Vn plus 1. It should be two consecutive terms. Now, when you add all of these terms, you will get only these two terms, one from the first, one from the last. After adding, S20 was 210 by 211, and there is no common factor between those two. So finally, m plus n will be 421, and hence the correct answer for this problem is second option. Consider an arithmetic progression and a geometric progression having the first four terms taken from this set. If the last term of these series are the maximum possible four-digit number, then we have to find the number of common terms in these two series. So here basically the problem is that we have to create an AP and a ZP, and we have to take the first four terms from this set, right? We have to take the first four terms of that AP as well as ZP from this set, and then we have to identify that how many common terms are there between the arithmetic progression and the geometric progression. Now AP and GP we have to find by observation only. So first let us talk about the arithmetic progression here. And it is not difficult to find those two by observation. You can very easily see that for arithmetic progression, if I take the terms as 11, 16, 21 and 26, so this will form an AP, right? First term 11, then you have 16, then 21 and then 26. And the last term of this series will be the maximum possible four-digit number. So the last term should be less than 9999. And you can very easily see that here we have multiples of 5 plus 1. So the last term will be 9996, right? This will be the last term of AP. Now, if I talk about the geometric progression, so again, it is not difficult to find the GP also. 4, 8, then you have 16 and 32, right? This will form the part of GP. So we have 4, then we have 8, 16 and 32. And again, the last number will be the maximum possible 4-digit number. Okay. And then we have to identify that how many common terms are there between the arithmetic progression and the geometric progression. Now, see here, if I had two arithmetic progression, then we have standard technique for finding the common terms of those two AP. But here, one is AP, another one is GP. So there is no formula to find number of common terms. Here, basically, the trick is that write all the terms of GP, and because in GP, the rate of increase will be very fast, right? I mean, here next number will be twice of previous number. So you will get only a few terms in GP, right? I mean, because the last number is maximum possible 4-digit number, and in GP, for example, here the next number will be 64, 32 into 2. After that, you have 128. So write the terms of GP, and then we'll see what are the terms which are also present in AP, right? That will be the process of solving this problem. So after 128, the next number will be 256, twice of 256, 512, twice of 512, that will be 1024. Then next number will be 2048, twice of this one, so 4096, and then 8192. After that, the next number will be bigger than the largest 4-digit number. So these are the terms of ZP. And now we have to identify that what are the terms common in AP as well as GP, right? We have to identify the common terms here. So in case of AP, you can very easily see that we have all the numbers of the form multiple of 5 plus 1. We have all the numbers whose unit digit is either 1 or 6, right? Here, if you want to write the general term will be uh, not the mth term, but in general term you can write as multiple of 5 plus 1. You have all the numbers of this form, right? 11 is 10 plus 1, 16 is 15 plus 1, and so on. So we have multiples of 5 plus 1, right? Now, in this one GP, this term 4 is not multiple of 5 plus 1, 8 will not work. 16 is one common term, it is multiple of 5 plus 1. 32 will not work, 64, 128 will also not work. 256 is another number which is multiple of 5 plus 1, or the unit digit is 6, right? Unit digit should be either 1 or 6. This one will not work. These two numbers will also not work. 4096, this is multiple of 5 plus 1, right? So here if we talk about the common terms between AP and GP, you can very easily see that these are the common terms. First common term is 16, then next number 256, and then next number 4096. The problem was we had to identify the number of common terms. So clearly there are 3 common terms, and therefore the correct answer for this problem will be 3, right? So in this problem, the important trick was that write all the terms of GP. In AP, we have numbers of the form multiple of 5 plus 1. Now identify what are the terms in GP which are multiple of 5 plus 1, or which have unit digit as either 1 or 6, right? So these are the 3 common terms, and hence correct answer for this problem will be 3. Consider the following two arithmetic progressions. First one is 3, 6, 9, 12 up to 78. For this AP, the first term is 3, common difference is also of 3. Then we have another AP, 5, 9, 13, 17 and so on up to 59 terms. And the problem is we have to find the sum of terms which are common in both the AP. Now in JEE Main, the problem on common AP is not uncommon. There are multiple PYQs from here. And in AP of common terms, basically there are two very simple concepts. First thing is that if we have two APs, then the common term that will also create another AP. And for that AP of common term, let us call that AP as common AP. So for the AP of common term, the common difference is LCM of common difference of two AP. That means here if I talk about the common terms, they will create another AP. And for that AP, the common difference will be LCM of common difference of these two AP. So for first AP, the common difference is of 3. For the second AP, the common difference is of 4. And therefore, for AP of common terms, the common difference will be 12. If I had 3 AP, then common difference will be LCM of common difference of all three AP. And the first term of common AP you can very easily find using by observations, right? So here, for example, you can see that 9 is the first term which is common in both the AP. So for common AP, the first common term will be 9 and the common difference is of 12. So therefore, common AP will be 9, then 9 plus another 12, so that will be 21. 21 plus 12, that will be 33. Another 12, 45. And in this manner, it will continue. Let us say last term is Tn. Now, in order to find a Tn, first we have to find the 70th term of first AP. And similarly, we need to find the 59th term of second AP, because the last term of common AP cannot be greater than the smallest of these two numbers, right? So if we calculate the 78 uh, term of first AP, it will be A plus 77D. A is 3 and n minus 1, so that is 77, and this multiplied by 3. So this will give us 78 into 3, which is 234, right? So this will be the last term of first AP. Similarly, for the second AP, the first term is of 5 and the common difference is of 4 and A plus n minus 1 into D. So this will be 58 into 4. So 58 into 4 plus another 5. So that will be 237, right? 232 plus another 5, 237. Now for common AP, let us say Tn is the nth term of common AP. So this Tn cannot be greater than 234, right? Tn, this has to be less than or equal to 234, because that is the smaller of these two numbers. The common term cannot be greater than 234 because the first AP will continue only up to 234. So if I can find n from here, then the problem is we need sum of common terms. So if I get n, then we can use the standard formula for finding the sum of n terms of an AP, right? Now, Tn is the nth term of this common AP, and that should be less than or equal to 234. Tn will be A plus n minus 1, and for common AP the common difference is of 12, so this should be less than or equal to 234. And from here, by solving this inequality, you will find that the value of n, the maximum value of n that will satisfy this is 19, right? You will get n less than or equal to 19 point something, so the integral value will be 19. That means in common AP there are total 19 common terms. Now the question is, what is sum of those 19 terms? So for that we have a standard formula, n by 2, 2a. A is 9. So n by 2, 2a plus n minus 1 into d. Right? This is the standard formula for finding sum of n terms of AP. N by 2, 2a plus n minus 1 into d. And from here you can see that this will become 19 into 2 you can cancel. So this will be 19 plus and then 12 into 9. So that is 108. So 118 multiplied by 19. You can do this calculation. After calculation, you will find that this thing will be triple to 3. So therefore, the right answer for this problem will be uh, 2, 2, 2, and 3, right? So this was again an interesting problem, and whenever you need AP of common terms, then first term you can always get by observation, and the common difference will be LCM of common difference of 2 AP. So find the first term, find the common difference, and then for number of terms, the nth term of common AP must be less than the smaller of these two numbers, right? So from there we got n as 19. Now sum of 19 terms, that will be this number, and therefore the right answer for this problem is 2223. Let A, B, C, D be positive real numbers such that their sum is 11. That is A plus B plus C plus D. This is given as 11. If the maximum value of A raised to 5 B cube C square D, this is 3750 beta, then we have to find the value of beta. Now, this is a very interesting problem from AMGM inequality, right? We know that if we have two positive numbers A and B, then their arithmetic mean, that is A plus B by 2, this is always greater than or equal to their geometric mean, that is AB raised to 1 by 2, where equality will hold if the numbers are equal, right? Otherwise, arithmetic mean is always bigger than geometric mean. Similarly, if I have three numbers A, B, and C, three positive numbers, remember we can apply the AMGM inequality only when the numbers are positive real numbers. So here it is given that A, B, C are positive real numbers. Now, if I have three numbers A, B, C, then A plus B plus C, and this divided by 3, right? For three numbers, their arithmetic mean will be A plus B plus C divided by 3, and this is greater than equal to their geometric mean, that is ABC raised to 1 by 3. And this AMGM inequality you can apply for any number of positive numbers, right? Now, here it is given that we have four numbers A, B, C, and D, and their sum is 11. Now, if I apply AMGM inequality on these four numbers A, B, C, D, then we are going to get A plus B plus C plus D, and this divided by 4, right? And on right hand side we'll get product of these numbers raised to 1 by 4. But remember, the product that we have to create, in that product we have A raised to 5, then we have B cube C square, and then D raised to 1. So obviously we cannot apply this inequality on these numbers A, B, C, D, because in that case the product that we'll get is A, B, C, and D. So here basically we have to split these numbers. If I have to create A raised to 5, right? So this A we can write as, we can split this number A as, instead of using the AMGM inequality on these four numbers, if I have to create A raised to 5, this A we can write as A by 5 plus A by 5 plus another A by 5 plus A by 5 plus A by 5. And now we'll take one number as this one, and we'll take A by 5 times so that we can get this product A raised to 5. Similarly, if I need B cube, then instead of B, we are going to write B by 3 plus another B by 3 plus another B by 3, right? Similarly, in place of D, in place of C, we can write C by 2 plus another C by 2. And in place of D, we are going to write D because we need D raised to 1. And now on these numbers, 5A by 5, then another 3B by 3, then 2C by 2, and one number D. On these 11 numbers, we are going to apply AMGM inequality. So that means here if I apply the AMGM inequality on these numbers, the numbers we are taking are these numbers. You have 5 times A by 5, then next three numbers are B by 3, then next two numbers C by 2, and then one number D. On these 11 numbers, if I apply AMGM inequality, then sum of these 11 numbers and that divided by 11. And notice that if I add these numbers, then we are going to get A plus B plus C plus D. Right? We are not using AMGM inequality on ABCD. We are applying AMGM inequality on uh, these 11 numbers. 5 of them are A by 5, next 3 are B by 3, then next 2 C by 2, and then one number D. So sum of these 11 numbers and that divided by 11, this should be greater than or equal to product of these 11 numbers raised to 1 by 11. And product of these 11 numbers will be A by 5, this raised to 5, then B by 3, this raised to 2, then C by 2 raised to 2, and D raised to 1. So on these 11 numbers, if I apply AMGM inequality, then we are going to get this result. And because it was given that A plus B plus C plus D is 11, so this left hand side is 11, and that divided by 11, so that will give us 1. And if I take 11th power on both sides, then we are going to get 1 is greater than equal to a raised to 5 b cube. Here b we had 3 times, so this will be b raised to 3, and then c square, and this multiplied by d, right? And this divided by, we have 5 raised to 5, then we have 3 cube, then 2 square, and then 1, right? Or I mean 1 you can write, the product will remain same. So this is what we are getting. And now from here one can clearly see that maximum value of this numerator, this will be nothing but 5 raised to 5 into 3 cube into 2 square. So basically 5 raised to 5 into 3 cube into 2 square. This is the maximum value of a raised to 5, b cube, c square and d. And this thing is given as 3750, and that multiplied by beta, right? So from here we can find the value of beta. Calculation you can do on your own. After uh, simplifying this one, you will find that beta is 90, and hence the correct answer for this problem will be option C, right? So this was a problem where we had to use AMGM inequality, but because we had to create this product a raised to 5 b cube c square and d, so we cannot use the inequality on these four variables a b c d. We had to split a as a by 5 5 times, similarly b as b by 3 3 times, c by 2 plus another c by 2, and d. And now on these 11 variables we are using the AMGM inequality. Finally, the maximum value of given expression, that was 5 raised to 5 3 cube into 2 square, and if I equate this with the given expression, then from there we'll get beta as 90, and therefore the correct answer for this problem is option C. Let alpha be this sum. Alpha is 1 square plus 4 square plus 8 square and so on up to 10 terms. And beta is another sum, which is sigma n raised to 4, n from 1 to 10. If 4 alpha minus beta, that is 55k plus 10, 40, then we have to find the value of k. Now, this is a very interesting problem from sequence and series. And here basically first we need to find the general term of alpha, right? In alpha, you have 1 raised to 2, 1 square, then 4 square, then 8 square, and so on. So, first let us try to figure out the general term in alpha, and then using sigma notation, we can find alpha, right? Alpha will be sigma Tn, where n is the Tn is the nth term of this series, right? Now, for this series, if you notice, 1, then next number 4, then 8 and 13, 19. So without this square, if you see the difference between any two consecutive term, that difference is forming an AP, right? Difference between 1 and 4, that will be of 3. Difference between 4 and 8, that will be of 4. 8 and 13, that is of 5, and so on. So difference between any two consecutive term without that square sign, that is forming AP. And we have a standard technique for finding the general term of a sequence where difference between any two consecutive term, that is forming an AP. So the general method is that let us say Sn is 1 plus 4. Remember, we are trying to find the general term without that square sign, right? So we are trying to find the general term of this sequence 1, 4, 8, 13, and so on, and then we'll square that one, right? So 1, then 4, 8, 13, and in this manner it will continue up to Tn. Let us say this is Sn. Now uh, write each term by shifting one towards right side. So we have 1, then we have 4, then 8, and in this manner the second last term, this will be Tn minus 1, and then we have Tn. Let us call this as equation 1, this one as 2. And now we'll do 1 minus 2. If we do 1 minus 2, we'll get 0 equals to 1 plus, and then 4 minus 1 will be 3, 8 minus 4, so that is 4, then 13 minus 8, that will be 5, and in this manner it will continue. Till this point we had n terms, but one term we have kept outside. So in this AP you will get n minus 1 terms, and this minus Tn, right? So from here Tn, or nth term of that sequence, that will be 1 plus and then sum of n minus 1 terms of this AP. So that is number of terms divided by 2, and this multiplied by 2a plus number of terms minus 1. So n minus minus 1, that is n minus 2, and this multiplied by common difference 1, right? So from here we'll get Tn as, you can simplify this one. After simplification, you will get Tn as 1 by 2 n square plus 3n minus 2. This will be the nth term of this sequence without that square, right? This will be Tn. Now we need 4, I mean, it is given that 4 alpha minus beta, this is 55k. So here if we talk about alpha, alpha will be basically sigma Tn square and n from 1 to 10. So basically alpha will be 1 by 4, and then you have n square plus 3n minus 2 square of this one. Obviously n is from 1 to 10, right? We need sum of 10 terms of this sequence. So this is alpha. Now we can cross multiply this one. So we'll get 4 alpha. This equals to sigma. And then here we can use a plus b plus c square formula. So we have n raised to 4 plus 9n square plus 4. And then twice ab. So that will be 6n cube. Then 12n, and then 4n square, right? This will be 4 alpha. Now it is given that sigma n raised to 4, this is beta, right? N is again from 1 to 10. So this term n raised to 4, that will be beta, that we can take on other side. So 4 alpha minus beta, this will be sigma, and then we can write this as polynomial. So we have 6n cube, 9 minus 4, so that is 5n square minus 12n plus 4. This is 4 alpha minus beta, right? Now it is already given that 4 alpha minus beta, this is 55k plus 40. Ultimately, we need the value of k. So in place of 4 alpha minus beta, we can write 55k plus 40. And on right hand side, we have sum of, we need to apply sigma individually on these different terms, and n is from 1 to 10. So 6 we can keep outside. Sigma nq, so n square, n plus 1 square by 4, and in place of n we have 10. So that means here you will get 10 square, 10 plus 1 square, so that is 11 square, and this divided by 4. 5 into sigma n square. Sigma n square is n plus 1, 2n plus 1 by 6, n is 10. So n plus 1, 2n plus 1, and this divided by 6, minus 12 into sigma n. Sigma n is n plus 1 by 2. So 10 into 11 by 2. And sigma 4, that will be 4n, and n is 10, so this will become 40. Now 40 you can cancel from both sides. And from here you can calculate the value of k. Right? Divide everything by 55, and then the calculation will not be that complicated. So when you solve this equation, you will find that k is 553, and therefore that will be the correct answer for this problem. Right? So this was a problem where first we had to get the general term, right? First observation that in alpha, without that square, these numbers 1, then 4, 8, 13, and so on. For this sequence, the difference between any two consecutive terms, that is in AP. So first let us find the general term of that sequence. For finding general term, whenever difference is in AP, you can use this standard method. Let us say Sn is this same sum, then subtract the 2, and from there we got Tn as half of n square plus 3n minus 2. Now alpha will be sigma Tn square, right? And beta was sigma n raised to 4, so we can take that on other side. After that, apply sigma operator on this one, and then finally, when you solve for k, you will find that k is 353, and hence the correct answer for this problem is 353. If Sn is the sum of n terms of an arithmetic progression, and the given AP is 3, 7, 11, and so on up to n terms, if this sum is between 40 and 42, right, sigma sk, k from 1 to n, and that multiplied by 6 by n plus 1. If this is between 40 and 42, then we have to find value of n. Now here first let us try to find Sn, and then we'll calculate the sigma Sk, where k is from 1 to n. So first let us try to calculate this expression, and then we'll see what is the positive integral value of n satisfying this inequality, because n is representing number of terms, so it cannot be fraction or negative number, it has to be positive integer. So first of all, if I have to find Sn is sum of n terms of this AP. The standard formula for finding sum of n terms is n by 2 and then 2a plus n minus 1 into d, right? Common difference is of 4. So this will be Sn, right? Now you can take this 2 inside, so then it becomes n into, here you will get 3 plus and then 2n minus 2. So this will become 2n square plus n. This is Sn, right? This will be sum of n terms of given arithmetic progression. Now we need to calculate sigma Sk, right? Now let us try to find this expression 6 by n plus 1, n into n plus 1, and that multiplied by the sigma Sk. So basically if I apply sigma on this one, 6 by n into n plus 1, this we can keep common, and sigma Sn and sigma Sk or Sn and k from 1 to n. So this will be nothing but 2 into and sigma n square, so that is n plus 1, and that multiplied by 2n plus 1, right? Sigma n square is n plus 1, 2n plus 1, and that divided by 6. So this will be the first term, and then sigma n, that will be sum of first n natural numbers, so that is n into n plus 1 by 2. First we'll simplify this expression and then we'll substitute here and try to figure out what is the value of n. Now if I take this term inside, then 6 will cancel, n into n plus 1 will also cancel, so we'll get 2 into 2n plus 1, and this multiplied by n into n plus 1 will cancel, so we'll get 6 by 2, that is 3, right? So basically this expression will be 4n plus 5, right? So when you simplify this one, this will become 4n plus 5, and it is given that this is between 40 and 42, and now we have to find the positive integral value of n from here. So subtract 5 from each one of these, so then 4n will be between 35 and 38. If we divide by 4, then clearly you can see that n will be 35 by 4, so 8.75. I mean, it is not difficult to see directly, you can see the result now. If we divide by 4, then this thing will be 8 point something, and on right hand side you will get 9 point something. So the integral value of n in that interval is 9, right? So that is the only positive integral value of n that will satisfy this inequality. And n has to be positive integer because it is representing number of terms. So the problem was we had to find the value of n, and clearly the value of n that will satisfy this inequality is 9, and therefore that should be the correct answer for this problem, right? So this was a problem where first we had to calculate Sn and then calculate sigma Sn. After simplifying, we got this expression as 4n plus 5. So 4n plus 5, that should be between 40 and 42, and from there we got n as 9, and that is the correct answer for this problem. A software company sets up m number of computer systems to finish an assignment in 17 days. If 4 computer system crashed on the start of second day, next 4 on the start of third day, and so on, then it took 8 more days to finish the assignment. The problem is we need to find the value of m. Now this is a problem from sequence and series, from arithmetic progression basically. Uh, Total m number of computer systems were in the beginning, and it was expected that in 17 days the assignment will be completed. But 4 system crashed on the start of second day, another 4 on the start of third day, and so on. And then it took 8 more days to finish the assignment. So then the problem is, what is the value of m? Now Here we can use unitary method for solving this problem. Let us say that if we had to complete the assignment in a single day, then the number of computer required, this will be 17 into m, right? M number of computer working for 17 days, they can complete the job. So if we have to complete the assignment in one day, the number of computers required, this will be 17 into m. And this must be same as sum of an AP, because I mean here on first day we have m number of computers working, then on next day we have m minus 4, right? Because 4 computers crashed on the beginning of second day. Then on third day the number of computers working, this will be m minus uh, 8, right? Here we have m minus 4, then m minus 4, another minus 4, so m minus 8. And in this manner it will continue. Earlier, it was expected that work will be completed in 17 days, but now it will take another 8 days. It will take 8 extra days to finish the assignment. So, total number of days required, that will be 17 plus another 8, 25. So, in this AP, basically you have total 25 terms. So, this is the equation that we are getting. If we have to complete the job in one single day, the number of computers required, this will be 17 into m, and on right hand side m plus m minus 4 plus m minus 8 and so on up to 25 terms. And now we have to solve for m. So from here you can see that 17m, and this will be we have an AP, and in AP the sum of n terms is n by 2, 2 into a plus n minus 1 into d, right? Common difference will be minus 4. So this is the equation that we are getting. Now from here one can write that 17m, this will be 25 into 2 we can take inside. So we have m minus, and then 24 into another 2. So that will be 48. So this is the equation that we are getting. And from here one can very easily see that value of m, this will be 25 into 48. This we can take on one side, and this divided by 25m minus 17m, so that will be 8, right? So from here we'll get 25 into 6, that will be 150. So that should be the value of m, and hence the correct answer for this problem will be option C, right? So this was a very interesting problem, and by using unitary method one can easily solve this one. Number of computer required uh, to complete the assignment in one single day, 17m, and this should be m plus m minus 4 plus m minus 8 and so on up to 25 terms, because now it will take total 25 days to complete the assignment. 17 days in beginning it was expected, and then another 8 extra day. After solving for m, we got m as 150, and hence the correct answer for this problem is third option. The positive integers are written in this form. In first row we have 1, next row 2 and 3, then 4, 5, 6, and so on. So basically we have first n natural numbers, and in nth row there are n numbers. In first row we have 1, next row 2, then next row, next 3 elements, and so on. The problem is if the kth row contains k numbers, for every natural number k, then we have to identify the row in which we have to find the row in which we have this number 5310. Now, this is a very interesting problem from sequence and series. And here basically we have to find the expression for first element of nth row. Once we get the first element of nth row, then we can figure out, then from there we can figure out in which row we'll have this number 5310, right? So basically we need a formula for uh, nth term, right? We need the formula for first element of nth row. Now here if you notice the sequence of first element, right? You have 1, then 2, then next number is 4, then you have 7, and so on. So if you take the difference between these two numbers, the difference is of 1. The difference between next two numbers, this will be of 2. The difference between 4 and 7, this is of 3. And you can very easily see that after 10, the next number will be 11, right? The fifth row will be starting from 11, and the difference will be of 4. So basically the difference between two consecutive terms is in AP. Right here, if we talk about the sequence of first element of each row, so for that sequence, the difference between any two consecutive term that will form another series which is in AP, right? And we know how to find the general term when the difference between two consecutive term is in AP, right? So the general method is that let us say Sn, this is 1 plus 2 plus 4 plus 7 and so on up to En, right? We are talking about the sequence of first element of each row. So we have here our aim is to find this Tn, the expression for general term Tn. So let us say this is Sn. Now whenever difference is in AP, then this is the standard technique for finding the nth term. Let us say this sum is Sn. Now we'll shift each term 1 towards right side. So we have 1, then we have 2. Here we'll get 4. In this manner it will continue. Here we have Tn minus 1 and the last term is Tn. And now we'll subtract these two. Right? If you do 1 minus 2, let us call this as equation 1 and this one as 2. So if we do 1 minus 2, we'll get 0 equals to 1 plus, and then 2 minus 1 will be 1, 4 minus 2 will be 2, 7 minus 4 that will be 3, and in this manner it will continue. Tn minus Tn minus 1. So basically here you can see that now we are getting an AP, and in this AP how many terms are there? So the answer is n minus 1 terms, because one term we have already kept outside, and at this point we have total n number of elements. So if I keep one term outside, then in this AP we have n number of terms minus Tn, right? Here we had 0, so 0 minus Tn, that will be minus Tn. And from here one can very easily get the expression for Tn, right? Tn will be basically 1 plus, and then you have sum of first n minus 1 natural numbers, for which the standard formula is n into n minus 1 by 2. So this is the expression for nth term, right? This will be using this formula, you can get the first element of nth row. You can very easily verify this result also. If I take n as 1, then we are getting this element 1. If I take n as 2, then we'll get 1 plus 1, 2. If I take n as 3, then we'll get 3 into 2 by 2. So this will be 3 plus 1, 4. Similarly, you can verify, you will get, if you take n as 5, then you will get 5 into 4 by 2 plus 1, that will be 11, right? And so on. So using this formula, you can get the first element of nth row. Now the question is, we have to identify the row which will contain 5, 3, 1, 0. So basically, if the nth row contains 5, 3, 1, 0, then this is the inequality that we have to solve. That 5, 3, 1, 0, this should be greater than or equal to Tn, and this should be less than Tn plus 1. And by solving this inequality, the value of n that you will get, that will be our answer, right? Because if this number is in kth row, or let us say nth row, so the first element of that nth row, that will be Tn. So 5310, that must be greater than Tn, and it must be less than Tn plus 1. Now here what we can do is that instead of solving these two inequality, we can simply solve this first inequality and find the largest value of n that will satisfy this one, right? Find the maximum value of n such that Tn is less than or equal to 5310, and whatever value of n we are getting, that will be our answer. This element 5310 will be in that particular row. So I mean, that will be another easier method of solving this one instead of solving the two inequality. So basically 1 plus n into n minus 1 by 2, this is less than equal to 5310. And now we have to figure out what is the maximum value of n that will satisfy this one. So we can write the same thing as n into n minus 1. This should be less than equal to 1, we can take on other side. So we'll get 5309, and then twice of that will be 10618, right? 5300. So 10600, and then 9 into 2, 18. So basically we need the maximum value of n satisfying this inequality. Also, you can see that n and n minus 1, these two are two consecutive integers. So if I approximately say that these two are same, then left hand side is basically n square or n minus 1 square. So now using hidden trial, we have to see what is the maximum value of n that will satisfy this. So let us take n as approximate square root of this number. So 10618, the square root will be 103 point something, right? So if I take n as 103, then what is the left hand side here? This will be 103 and this multiplied by 102. So this will become 10506, right? We can break this as 100 plus 3 into 100 plus 2 and then multiply the 2. So if I take n as 103, this will be the left hand side, and obviously this number is smaller than 10618. Also, if I take the next possible value n as 104, then left hand side will be 104 into 103, and this will be 10712, which is bigger than this number. We need the largest value of n satisfying this inequality. Clearly the largest value of n that will satisfy is 103. How we thought of 103? Approximate square root of this number, right? Because on left hand side n and n minus 1, those two are approximately same. So from there we got, these two possible values. 103 is satisfying the inequality. 104 is giving us a number greater than this right hand side. So the maximum value of n that will satisfy this inequality is 103. And therefore, this particular element 5310, it has to be in 103rd row. And therefore, the correct answer for this problem will be 103. Right? So this was a very interesting problem. First, we had to make this observation that for the sequence of first element of each row, the difference is in AP, and therefore to find the nth term of this sequence, we can use the standard method when the difference between any two consecutive term is in AP. So we got Tn as this one, and now if 5310 is in nth row, then this number should be greater than Tn and less than Tn plus 1. But instead of solving this inequality, we can solve only this first one and try to find the maximum value of n satisfying that inequality. Using hidden trial, maximum value of n that we got was 103, because 104 is giving us a number bigger than this right hand side. So the largest value of n satisfying that inequality is 103, and hence the correct answer for this problem is 103. Let Sn represents this sum 1 by 2 plus 1 by 6 plus 1 by 12 and so on to n terms. If sum of the first 6 terms of an AP with first term minus 6 and the first term minus P and the common difference plus P is this one, root over 2026 and this multiplied by S of 2025, then we have to find the magnitude of difference between the 20th term and 15th term of this AP. Now in this problem, first we need to calculate this Sn so that we can figure out the value of S 2025, and once we have this value, then we'll see that how to find sum of an AP with first term minus P and common difference plus P. So here, first we need to see the pattern in Sn. So you can see that we have 2, then 6, then 12, 20 and so on. This 2 is 1 into 2, 6 is 2 into 3, right? 12 will be 3 into 4, 20 is 4 into 5. So that means if you write the general term Tn, then clearly you can see that this will be 1 by n into n plus 1, right? In first term we have 1 into 2, then we have 2 into 3 and so on. So this is the general term Tn, and when these type of problems are very common in JEE Main, where using method of difference we have to find the sum of n terms of this series. So the first step will be that we need to write Tn as Vn minus Vn minus 1. This is the standard method, that we need to write Tn as difference of two consecutive terms. We also call this Vn method or method of difference. So here write the general term as difference of two consecutive term, and then when we add, the alternate terms will cancel. So for that, this 1 in numerator, that you can write as n plus 1 minus n, and this divided by the denominator part will be n into n plus 1. And now you can see that when you separate the two terms, then you will get 1 by n minus 1 by n plus 1. So this is the general term Tn, right? Now here if I calculate T1, the first term itself, this will be 1 minus 1 by 2. Similarly, the second term 1 by 6, this one can write as 1 by 2 minus 1 by 3. The third term 3 into 4 or 1 by 12, this you can write as 1 by 3 minus 1 by 4. And in this manner, the last term Tn, this will be 1 by n minus 1 by n plus 1. So this will be Sn, right? These are the different terms. Their sum will be Sn. So now clearly you can see that if you add all of these terms, then 1 by 2 will cancel, 1 by 3 will cancel, and so on. So from here, when you add all of these terms, you will get Sn as you have 1 from here, right? And 1 by n plus 1. All the other terms, they will cancel. 1 by 2 will cancel, 1 by 3 will cancel, and so on. And the second last term, the second term will be 1 by n, so that will cancel this 1 by n. So ultimately we have 1 minus 1 by n plus 1, and this will become n by n plus 1. So this is sum of n terms of that series, right? Now it is given that sum of first 6 terms of an AP with first term minus p and common difference plus p is that number is 2026, and this multiplied by s of 2025. So sum of 6 terms of AP, that will be 6 by 2, and this multiplied by 2 into A is minus P, and plus n minus 1, n is 5, so n minus 1 will be 5. Common difference is P, and this sum is square root of 2026, and this multiplied by S 2025. Now S 2025 means 2025, and this divided by 2026, and this raised to 1 by 2. And now by solving this one, we need to find the value of P. So clearly you can see that 2026 will cancel, and from here you will get 3 into 3P, and root over 2025, that will be 45. So from here we'll get the value of P as 5, right? Now the problem is we need the difference between, so the value of P is 5, and for the given AP, the common difference is of 5. Now we need the absolute difference between the 20th term and the 15th term. So clearly you can see that difference will be nothing but 5D, right? 20th term means A plus 19D, and 15th term means A plus 14D. So the difference will be 5 times the common difference. Common difference P is 5. So therefore this will become 25. So the correct answer for this problem will be fourth option. So this was a very standard problem of method of difference. First write the general term as difference of two consecutive terms. Then from there we got Sn as n by n plus 1. And now after that standard formula for sum of n terms of AP. So finally the correct answer for this problem is 25. The interior angles of a polygon with n sides are in AP with common difference 6. If the largest interior angle is 219 degree, then we need to find the value of n. Now, before we attempt this problem, there is one simple formula that you should know, that in case of any polygon, sum of all the interior angle, this is n minus 2 into 180 degree. For example, if I have a triangle, then sum of all the angles will be 180 degree. So that is 3 minus 2 into 180. In case of a quadrilateral, 4 minus 2 into 180, that will be 360. In case of a pentagon, 5 minus 2 into 180, that will be 540, and so on. So in case of a polygon of n sides, in case of polygon of n sides, sum of all the interior angle, this is always n minus 2 into 180. Now here it is given that the angles of a polygon are in AP with common difference 6, and the largest angle is 219 degree. So if the largest angle is 219 degree and common difference is 6, so the next angle will be 219 minus 6, that will be 213 degree. This will be the second largest. Similarly, the third largest will be 213 minus another 6, so 207, up to, let us say that last term is nth term. We have n-sided polygon, and so now These are the different angles of the polygon 219, 213 and so on up to Tn. And we know that sum of all angles must be n minus 2 into 180. So now we have to use formula for sum of n terms of AP, equate with this number and then find the value of n. So n minus 2 and this multiplied by 180, this is sum of all the interior angles. And if I use the formula of sum of n terms of AP, then n by 2, 2 into A plus n minus 1 and into common difference D. Now, because we are writing the AP in decreasing form, we are writing the first term, we are writing the last term first. So common difference will be of minus 6, right? And now we need to solve this equation. So n minus 2 into 180 degree, and on right hand side you will get n into 2 we can cancel. So we have minus 3n and then 3 plus 219, so that will be 222 degree. Now 3 you can take common from here, so then we have n minus 2 into 60 degree, and this will be equal to n into minus n and 222 divided by 3, so that will give us 74 degree. So from here I think we are getting n square plus 60 minus 74, so minus 14n and then minus 120, this equals to 0. This is the quadratic that we are getting, and you can very easily see that we can split at minus 20 and plus 6, so the factors will be n minus 20 into n plus 6 equals to 0, because n is representing number of side, n cannot be negative. So from here we are getting n as 20. So that will be the correct answer for this problem. Total there will be 20 sides in that polygon, right? So this was a very basic problem, you can say. If you know this formula, that sum of all the interior angles in a polygon of n side is n minus 2 into 180, then this is the sum that we'll get using a standard formula. And on right hand side, we have sum of in terms of AP with first term 219 and common difference minus 6. After solving, we got n as 20, and that will be the correct answer for this problem. If 1 by 1 raised to 4 plus 1 by 2 raised to 4 and so on up to infinity, this is pi raised to 4 by 90, and 1 by odd number raised to 4, this is given as alpha. 1 by 1 raised to 4, 3 raised to 4, 5 raised to 4 and so on. And similarly 1 by even natural number raised to 4, their sum is given as beta. So then we have to find alpha plus beta. Now at first it might seem complicated problem, but it is one of the easiest problem from this chapter sequence and series. The very first observation, if I add alpha and beta, right, one equation you can get from here, that alpha plus beta, this will give you sum of 1 by 1 raised to 4. From here you will get 2 raised to 4, 3 raised to 4 and so on. So this thing is nothing but alpha plus beta, right? Alpha plus beta, this is pi raised to 4 and this divided by 90. This is one equation. And from here in beta you have 1 by even number raised to 4. Now if I take uh, 2 raised to 4 common from all of these, right? If I take 1 by 2 raised to 4 common from all of these terms, then the very first term will be 1 by 1 raised to 4. Next one will be 1 by 2 raised to 4, right? This 4 we can write as 2 into 2. 2 raised to 4 we have taken common. So next term will be another 2 raised to 4. Similarly, 1 by 6 raised to 4. 1 by 2 raised to 4 we have taken common. So this will become 3 raised to 4. And this thing will continue up to infinity. This is given as beta, right? Now, this sum is already given. This one is pi raised to 4 by 90. That means beta is nothing but 1 by 16, and this multiplied by pi raised to 4 by 90. This is beta. And alpha plus beta, this one is pi raised to 4 by 19. So if I substitute this value of beta here, then alpha will be 1 minus 1 by 16. So that is 15 by 16, and this multiplied by pi raised to 4 by 90. And now the problem is we need to find alpha by beta. So clearly you can see that everything will cancel, and alpha by beta, this will become 15. and hence the correct answer for this problem will be option D. Right, so this was one problem where one equation you will get from here. If I add these two, then alpha plus beta, this is pi raised to 4 by 90, and simply by taking 2 raised to 4 common from this one, you can get the remaining, you can write the remaining sum as pi raised to 4 by 90, and that will give you the value of beta. From there calculate alpha. Finally alpha by beta, that will be 15, and hence the correct answer for this problem is fourth option.